Hello everybody and welcome to this topic. The topic for today's discussion is facilities layout. Last time we have seen about facilities location. Under facility location we have discussed about critical success factors, different methods which are used to evaluate all. Under facility layout we specifically discuss about the topics, definitions of facility layout, objectives of facility layout, principles of facility layout, those principles that we consider when we design new facility layout, classification types of facility layout, and criteria of good facility layout. Let's see one by one. Facility layout refers to the physical arrangement of the production facility. In short, the arrangement of all resources within the company, or we can say the locations of each facility within the backyard, within the compound of the firm. It is the configurations of departments, including work centers, equipment, even the employees in the conversion process. That means the arrangement or the configurations of all resources engaged in the process of conversion. Or we can define as it is a floor plan of physical facilities which are used in the production process. According to Moore, it is a plan of an optimum arrangement of facility. An optimum facility. That means no more better facility can be obtained, including personnel, operating equipment, storage space, material handling equipment, and all other supporting services, along with the design of best structure to contain all these facilities. The arrangement or the configurations of all the resources engaged in the conversion process, or the locations of those resources within the compound of the firm, Last time we have seen the broad aspect, that is the facility location. But today, after we select the location and after we establish the specific location, today we are going to discuss about the locations or the layout of those specific facilities, those specific equipments, personnel, work center, department, warehouse, stores, and so on. Layout decisions include the best placement of the machines. That means by the best placement, we mean that the appropriate, the convenient locations of that machines, which reduces the cost and which can maximize the profit, which can maximize the conveniency of the employees or increase the satisfactions of the employees, office and desks or service center in different settings. The best placement of not only machines, but also office, desks, and or service centers in different settings. An effective layout, by the way, facilitates the flow of materials. Not only the flow of materials, but also flow of people and information within and between the areas of the firm. So an effective layout facilitates or increases the speed of material flow, people, information within the compound. The more efficient layout requires the less labor. This is an advantage in reducing the cost. The efficient layout requires less labor, reduce wastes, and provides faster service. Indirectly, it reduces the overall cost and maximizes the overall profits of the organization. The objective of layout strategy is to develop an effective and efficient layout. That is the optimum layout, the optimum placement of the facilities within the organization that will provide the firm's competitive requirements. The These are the needs of facility layout decisions, or the situations or the conditions that we need to decide in terms of facility layout. These are the particular situations. These are the situations. The need for facility layout decision means when we need facility layout. At what circumstances do we need facility layout? The first one is when there is inefficient operation. When there is inefficient operation, we have to change something. We have to change those bottlenecks. So we rearrange, we reconfigure our layouts in the case of inefficient operation by thinking that when we make appropriate configuration or arrangement of facility layout, it may reduce or it may increase our efficiency. And the other case is change in the design of product or service. It is obvious that when there is a change in the product, the existing product or service, we have to align our facility layout so that it will give us the new product or the new design of the product. So we have to change our layout as well. And the third one is the introduction of new product or service. When we introduce new product, it is obvious that we have to change our process, we have to change our layout as well. And the other is in the case of accidents. If there is frequent accidents, if we face a lot of accidents, so we have to change our facility layout. So this may be the reason to change our facility layout. Or this may be an alarm for the firm that there is a need of facility layout decision. These are the overall circumstances that makes the company to change, that makes the company to make a decision on facility layout changes. Now let us see the objectives of facility layout. The primary goal of any plant, the primary goal of the plant layout is to maximize the profit. This is obvious. By smooth flow of work, materials, information, or arrangement of all the plant facilities. By bringing smooth flow of work, materials, information, or arrangement of all the plant facilities, we can achieve the maximum profit. Specifically, there are certain objectives that can be achieved through good facility layout. Higher utilization of space. By using good facility layout, we can use all our spaces effectively and efficiently. We can use the time, we can use equipment, we can use our people, our employees. In short, we can maximize the utilization of our resources. And the other objective is it improves the flow of all those resources in the conversion process, engaged in the conversion process. Improved flow of information, materials, or peoples along the process. It facilitates the flow of information, materials. It speeds up the flow of those resources. And the other is improved employee morale, safer working condition. Not only it brings improved flow of information, it also improves the employee morale, motivation, satisfaction, engagement, or commitment, and so on. It can also be safer working condition. It increases the conditions of the working. It increases the safety of the working conditions. It also improved even the customers and the client's satisfaction, or customer service or client interaction. It also improves the customer or client interaction with our employees, with our customer service. It also achieves the flexibility. Facility layout should be flexible because it can handle different demands, or it can handle various changes. whatever the layout is now, it will need to change in the future, because there are different circumstances or different situations that obliged the firm to change the product, to change the process, to change. So those changing process and product also demands to change the facility layout. Coming to the principles of facility layout has the following principles. That means when we design a new facility, when we introduce new facilities based on the different situations, we have to keep in mind that we have to remember those principles. The first principle that we remind while designing a new facility layout is integration. All our resources, main materials, machines, and supporting devices have to be considered. If we forget one, so there will be a mess when we use that facility layout. So we have to integrate, we have to consider main materials, machines, supporting device, or optimum utilizations of resources and maximum effectiveness. This should be considered. And the other is minimum distance. As the distance increases, we know that transportation cost or material handling cost will also increase. So we have to keep in mind that we have to minimize, we have to reduce the distance of the movement. Minimum travel of maybe man and materials is necessary, essential in order to reduce the cost. As far as possible, straight line movement should be preferred. As far as possible, it is better to choose to select straight line movement than the other shape or the other types of movement like circular or curve type and so on. And the third one is cubic space utilization. By cubic space utilization, we mean that we have to consider not only the horizontal, that is the XY plane, but also the vertical space should be considered. The height is also utilized effectively. We have to use the height of our rooms effectively so that we can increase the cubic space utilizations. And the fourth one is principle of flow. Materials, as we know, all resources are coming together, and we enter and we compile those resources and we enter into the process of conversion, and at the other place we get the output. So materials forward direction towards the completion state. This is a principle of flow. We have to consider the materials forward direction toward the completion stage. The next principle is principle of maximum flexibility. It is obvious that the facility layout have to be maximum, as much as possible, flexible. Or we can say it should be changed with minimum cost for the future requirements, because we have different requirements, we have different situations or different circumstances that demand us to change the facility layout. During that case, if the facility is more flexible, so we incur less cost, so we can change, we can alter to different layouts easily. So it should be maximum flexibility. Consider maximum flexibility. And the sixth one is principle of safety, security, and satisfaction. These are the crucial concepts. The safety, security, and satisfaction also have to be kept in mind when we design the facility layout. Workers, that means the worker safety, maybe the machine safety, the equipment safety, satisfactions of the workers, satisfactions of the employees, and safeguard of the plant and machinery against fire, theft, and different accidents have to be considered when we design the facility layout. And the other is principle of minimum handling. Principle of minimum handling means a good layout is the one that reduces the material handling to the minimum. By reducing the handling, we can decrease the handling cost of the materials or the product or the resources. Let's come to features of layout decision. These are the characteristics or the aspects of layout decisions. The first one is it requires substantial investment of money and effort. It requires big amount of capital. In order to change the facility layout, it requires huge amount of money. And the other is it involves long-term commitment. By the way, the first feature and the second feature is related because it requires substantial investments. We will not change those facility layouts frequently. So it is a long-term commitment. It is a long-term commitment because it needs huge amount of money to change frequently. And the other is it has significant impact on cost and efficiency of short-term operation. In the short term, in the long term, we will change to the other facility layout, but in the short term, it has an impact on both costs, maybe transport cost, material handling cost, and different operation costs, and it also affects in terms of efficiency, being efficiency. Let's come to layout design procedures. In general, there are two types of layout design procedures. The first one is manual method. Manual method, we design a layout using manual method without using computers, without using different softwares. So we can use manual methods, or the second one is computerized method. This is sophisticated, by the way, and this one is better to choose than the manual methods. Here, we continue till no further possibility to reduce the transportation cost. Here, we consider reducing the transportation cost. We reduce the transportation cost till no more reduction is possible. Till no more reduction is possible. In this case, we take an input. Those requirements are, those given data should be parameters are initial layout, flow data, cost per unit distance, total number of departments, fixed departments, number and locations of the departments, and areas of the departments are provided for the computers to calculate the best possible layout which provides the lowest transportation cost. Now let's come to classifications or types of facility layout. There are four major types of facility layouts. The first one is product layout, second process layout, combination layout of process and product layout, and the other is fixed position layout. Let's see one by one. The first type of layout is product layout. In this case, equipment or departments or machines are dedicated to a single particular product line. Resources, that is equipment or departments, are dedicated, specifically assigned to a particular product line in the case of product layout. And backtracking is avoided and a straight line flow of material is achievable. Machines and auxiliary services are located according to the processing sequence of the product. Those equipments, departments, machines are provided or assigned for a particular product, and no backtracking is not possible or avoided, and the straight line flow of materials can be achieved through this type of layout. Special machines are used to perform the required functions quickly and reliably. It is selected. This type of product layout can be selected in the case when the volume of production of a product is the volume of the production, or the volume of the production is high, which requires a separate production line. For example, assembly line or mass production. In the case of high volume of production, we can use this type of layout. In a strict product layout, machines are not shared by different products because they are dedicated or they are assigned for a particular product. So we cannot share machines to different types of products. Therefore, the product volume must be sufficient because we cannot share those machines. The product volume must be sufficient to achieve satisfactory utilization of those dedicated equipments. In this case, in mass production, the assembly line balancing is necessary to minimize the idle time. Here there are different parts of the machines. There are different modules or different parts of the machines exist, so the speed of those all specific machines should be the same. Let us see some designing product layout. That is, line balancing is the process of assigning tasks to workstations. There are different workstations and overall equipment in such a way that the workstations have approximately equal time requirements. If one finishes and the other delays, there is a problem, and the reverse is also has a problem. So line balancing is the process of assigning the tasks to workstations in such a way that the workstations have approximately equal time requirements, or we can say the workstations have equal speed in finishing the tasks. In a sequence of activity, all those machines require the same time to finish their assigned tasks. So when the first machine finishes, the second also should finish in order to receive the first activity from the first machines. In this case, there is another concept that's cycle time. It is the maximum time allowed at each workstation to complete its set of tasks on a unit. These are the formulas in order to calculate the cycle time, the output rate, and so on. For example, output rate can be calculated by operating time per day divided by cycle time, and cycle time can be also calculated as operating time per day divided by desired output rate. And minimum number of workstations required for the particular tasks can be calculated as summations of task time divided by cycle time. This is the precedence diagram. This figure shows the precedence diagram that shows how the activities are flowing in a process. For example, here the activity A should be finished before we start the activity B. Or B and C, both B and C will be finished before starting D. As soon as we finish both B and C, we can start D. And in order to start E, we have to finish the activity at D. This shows the precedence diagram. This figure clearly shows the product layout. First, at the beginning, we have to compile all the resources, or all the resources are coming together, and we enter into station 1. Then, after we finish at station 1, we provide to station 2, then station 3, and so on. Work is flowing from the beginning to the end, like this. So in this case, when the production or the conversion is continuous, so the speed of all these workstations should be the same. The speed of all these workstations should be in order to reduce the idle time, or in order to increase the utilizations of all the stations. So the line balancing should be incorporated. In this case, line balancing should be incorporated. And this is a specific examples. Let's see the merits or advantages and disadvantages or limitations of the product layout. The first advantage is a smooth and logical flow. It is a smooth and logical flow because it starts from the beginning stations and ending in the other stations. In-process inventory is less because it is fully automated, or we use dedicated machines, so in-process inventory is less. Minimum material handling cost. Because of the inventory, the in-process inventory is less, so we can achieve minimum material handling cost. Usage of mechanized handling systems and unskilled workers can manage the production because the labor contact is less, so we can use mechanized handling system. In this case, labor contact is less, so even we can use unskilled workers who can manage the production. And the manufacturing cycle is short because of the automations, because of the automatic machines, the dedicated special machines. So the manufacturing cycle is short, and the manufacturing cycle is short due to uninterrupted flow of materials, and we can get huge amount of or high volume of the production. Low unit cost and high rate of output. Because our product is high volume, so the low unit cost can be achieved, and high rate of output is, on the other hand, can be possible. On the limitation side, a breakdown of one machine is product line may cause stoppage of the next machine because they are put in sequence in a sequential manner. A breakdown of the first machine may affect the work of the second machine because the second machine gets its input from the first machine. Once the first machine cannot work, so the remaining machine, the subsequent machine, will be idle. And this one is the second actually. This one is the second one. A change in product design need major change in the layout because the machines are specialized machine which is dedicated for a particular product. Once we want to change a product design, we have to change all that layout. Comparatively high investment and equipment is required. It is obvious that we have to use specialized machine in product layout, so it needs or demands comparatively high investment to get that special machines, and lack of flexibility is also another limitation. Because we cannot use that special machine for the other purpose, there is lack of flexibility, and these are the limitations. Let's come to the process layout, the second layout. This is also called job shop or functional layout, in which similar equipment or functions are grouped together. In the case of process layout, all those equipments or machines which are similar can be grouped together, And the objective is to minimize interdepartmental material handling cost. If we cannot group those similar purpose machines together, there is a material handling cost. We have to move one material, the output of one equipment, to the other machines. But if we group those similar purpose machines together, so there is no movement of materials from one machine to the other, or we can reduce the material handling cost or interdepartmental material handling cost. Here, we have to keep in mind that interdepartmental flow of activities or number of movements, building and departmental dimensions have to be considered, have to be reminded. all machines performing similar type of operations, as we said before, are grouped at one locations in the process layout. In the process layout is characterized by allocating or grouping those similar purpose equipment or machines together. And it is recommended for batch production. This one is recommended for the batch production. Facilities are grouped together according to their functions. We already said it is locating similar transforming resources together so that different products or services with different processing needs will take different routes through the operations. This picture clearly shows what this sentence talks about. It is locating similar transforming resources together so that different products or services can be achieved from similar transforming resources. Process layout is normally used when the production volume is not sufficient to justify the product layout. By the way, if the volume of our production is high enough to justify the product layout, so we have to move to the product layout. But if the volume is less, so we establish process layout. This figure shows how the process layout looks like. First, there is milling machines are grouped in this room, and welding after milling machines, so welding machines are grouped together here, and the next grinding machines are here, then inspection machines or inspection department is assigned here, and here other departments, and then assembly, and so on. These machines are here. In the case of milling machines, all the milling machines are located together in one room. So if we are putting those resources in milling machines, here there are different types of milling machines which can grind those resources as per our demands and provide to the welding machines. This is an example. Of process layout. Here, flow between departments. This table shows the interdepartmental flows. The flow, there are 8 departments, 1, 2, 3, 4, 5, 6, 8 departments, 1, 2, 3, 4, and the activity in each department is this one. For example, in Department A, shipping and receiving, Department 2, plastic modeling and stamping, Department 3, metal forming, and so on. These are the activities in each department. And this is the building, the configurations of the building. That is consists those 8 departments. And this number requires the moves. For example, from Department 1 to Department 2, there is a move of 175. And from Department 1 to Department from Department 1 to Department 8, there is a move of 25. So based on the moves, we can calculate, based on the frequency of moves, we can calculate the costs, not only the frequency, but also the distance should be considered. Both the distance and the frequency is considered to calculate the transportation cost. So we have to rearrange those departments so that it will bring the minimum possible costs, so that it will give the lowest possible cost of transportation. So this is a table form, and this one is a diagram. They are the same. They show. Moving to the advantage and limitations of process layout. By the way, it is possible to get these advantages and limitations from what we have discussed about the process layout. The first advantage is flexibility of the equipment. When we compare with that of product layout, there is here some more flexibility. Some more flexibility of the equipment and personnel is possible in the process layout because similar purpose machines are grouped at one location at a single room. So there are flexibility. If the one machine is broken, for example, so we can use the other similar purpose machines. And lower investment is possible, or less number of machines and lower costs. We can use those machines because all the machines located at one place are similar purpose machines. We can replace one machine with the other machines. Here in this case, in the process layout, we are not using specialized purpose machines which is dedicated for a single product. So we can alternatively use those similar purpose machines. And higher utilizations of production facilities. Supervisors become knowledgeable about their functions. In a single functions, we have a lot of equipment or machines which are similar in purpose, so that supervisors may upgrade his skills in controlling or managing those equipment or machines. The limitations: long movements may occur, reducing material handling efficiency. We are not using special purpose machine here. We are using similar purpose machines, so there is a problem of material handling. Material handling cannot be mechanized or cannot be automatic, and it may increase the cost, and it lowers the productivity due to number of setups. We have to change the setup of that machines in order to produce different products. That requires costs and it decreases the productivity. And the other is space and capital are tied up by work in process because we are not using automatic or material handling equipment. This is the third type of facility layout, that is combination layout. By combination, we mean we combine both process and product layouts. We are getting the advantages of both product layout and process layout. By combining the two, we can maximize our advantage, our benefits. A combination of process and product layout combines the advantage of both types of layout, and a combination layout is possible where an item is being made in different types and sizes. When an item is made in different types and sizes, so we require both benefits from product and process layout. In this case, machinery is arranged in a process layout, but the process grouping is then arranged in a sequence to manufacture various types and sizes of the product. You see this sentence: the machinery is arranged in process layouts, that is, similar purpose machines are arranged in one location, but the process grouping is then arranged in a sequence, that means in a product layout type, in order to get various types and sizes of the product. So we can bring those advantages together, those product and process layout advantages. It is to be noted that the sequence of operation remains the same with the variety of products and size. It's to be noted that the sequence of operations remains the same with variety of products and sizes in the case of combination. This is a type of process layout, that is functional layout, because here similar purpose machines or similar purpose machines or similar purpose equipments are grouped together and used for intermittent processing, for job shop and batch process. For example, these are the university departments, and the activities, similar activities are conducted in department A, and the other types of activities which are similar may be assigned to department C. And these are the product layouts, which is sequential. So when we combine both product, process layout, and product layout, the activities, similar activities are grouped together, and those departments are arranged in a sequence. So we can get the maximum advantage from the combination layout in order to get different sizes and different types of output. And the last one is fixed position layout. As the name indicates, it is a layout in which the product or the project remains stationary and workers, materials, and equipment are moved as needed. The products will be fixed or will be stationed at some places, so the other required materials or resources are coming together to get that project. It is also called a project type layout. Nature of the product dictates this type of layout. The nature of the product dictates this or requires this type of layout. For example, if the nature of the product, that means if the weight is higher or the size is huge and it is bulky, so we require fixed position layout. The ships, the dam, or different type of bridges are built with fixed position layout, because their weight is high and the size is also very big and it is bulky, so it's not possible to move those products. So we require to move workers, materials, and equipment. In order to build dam, in order to build bridge, or in order to build ship. It is suitable when one or a few pieces of identical heavy products are to be manufactured. When the assembly consists of a large number of heavy parts, the cost of transportation of this part is very high. It requires high amount of transportation costs, so we have to bring the workers, material, and equipment to make that product. For example, large construction projects are built on a specific site, in a site. Now let's see benefits of good facility layout. Or good facility layout considers material handling equipment, conveyors, cranks, automated storage and retrieval systems, and automatic carts to deliver and store materials. We have to consider material handling equipment, capacity and space requirements. We have to fulfill the capacity and space requirements, environment and aesthetics. It brings pleasure for the employees or for the customers. Layout concerns often requires a decision about window, planters, and height of partitions to facilitate airflow, reduce noise, provide privacy, and so forth. Flows of information, or in general, flows of materials, flows of resources, cost of moving between various work. Coming to the service layout, we know that there is a difference between goods and services. So far, we have discussed about products or tangible products, and now we will see about service layouts. Majorly, service layout can be categorized into office layout and retail layout. In the case of office layout, we have to consider the grouping of workers or the type or the characteristics of workers. For example, the employees working in a finance departments are grouped together, and their equipment, their computers, their table chairs are grouped along with them, and spaces which is sufficient for which provide comfort, safety, and it is which is convenient for the movement of information is provided for those workers. We have to consider these issues. And in the case of retail layout, the sales and profitability vary directly with the customer exposure to the product. When the customers are exposed to the product, so they become interested and they create initiation, or they become motivated to buy that product. So the retail layout should be in a way to expose the products for the customers. For example, if we consider the supermarkets, they arrange those products, similar products, in one shelf. So the customers are watching clearly those products, so they become interested to buy those items. Studies do show that the greater the rate of exposure, as the rate of exposure increases, the greater the sales and the higher the return on investment. So we have to consider the exposure to the customers when we arrange our facilities, when we arrange our items. So we have to consider that they are exposed as much as possible to them. Let's do an example. A university advising office has 4 rooms, that is A, B, C, and D, each dedicated to specific problems. The office is 80 by 20. The dimensions of the office is 80 by 20, and each office has 20 by 20. The dimension of each office is 20 by 20, and there is an interaction between the two offices. There is an interaction between the two offices, and the interaction is given as A and B has an interaction of 10, A and C 20. So A and C has greater interactions than A and B, and A and D has 30. So A and D has more interactions than the remaining. So this is the interaction, and the dimension is 20 by 80. So let's assume that in order to move from A to B, the cost is 1. From A to C, the cost will be 2. And from A to D, the cost will be 3. So these are the costs, and these are the dimensions, the lengths, the dimensions. And from A to B, there is 10 interactions. There is 10 frequency times 1. It will be 10. And we calculate the remaining costs equals the frequency times the cost. So we get the cost here. The current cost is 195. 195 is the cost incurred with the existing configuration. So now let's improve the layout by exchanging the functions within the rooms. When we exchange the functions in the room, we have to take care that we have to consider the highest frequency should be aligned to side. The highest frequency should be aligned side to side. And let's move A to D. Let's make A and D side to side because there is highest frequency or contact interaction between A and D. Let's put A and D together, and let's put B and C as it is, and let's just move only A to D, and let's evaluate these locations. When we evaluate these locations, we get 155. So 155 is less than 195, so it is a better layout than. This is another example. You can do it by yourself. By the way, it is a solved example, so you can do it by yourself. If you have any problems, you can write on the comment box. This is all about today's discussion. If you want further expand your knowledge, or if you want further reading, so these are the references you can read. Have a good time. Bye.